So sets and subsets. These are things that y'all have talked about for a couple of years. We're going to expand it a little bit. So we are used to a set of rational numbers, right? Integers, whole numbers, fractions, or rational numbers. So the set of rational numbers and the set of irrational numbers together form the big picture idea set of real numbers. So real numbers encompasses everything. It's like the big umbrella that falls over all of them. So we've got ourselves a graphic organizer here. So the big rectangle that has everything in it are your real numbers. Okay. Inside of real numbers, the first break off that happens is your rational numbers and your irrational. You see how inside the rational box we've got more and more nested boxes, but inside irrational, keep that. Because that's as far down as you can break down irrational numbers. We talked a little bit about them last week because we were talking about non-perfect square roots, right? What do we know about non-perfect square roots?
They're not perfect. Like they can't be like
perfect.
They can't be like 4 times 4. They have to be like 4.
So when we take the square root of something like the square root of 12, like we did for 1, right? If I put it on a calculator and I took the square root of 12, because it's a non-perfect square, I'm not going to be able to predict what decimals. We can estimate it, right? But if you actually took the square root of it, there's no pattern to my decimal. The definition of a rational number is something that could be written as a fraction, which means that an irrational number can't. It also is not a terminating decimal. Y'all remember that from last week? Terminating meaning like 4.5. It stops. Everything after that is 0. Or a repeating decimal. 6.7, 777, right? On and on and on and on and on. It goes on. You can predict that the 10th decimal is a 7 and the millionth decimal is a 7 as well. So one of our examples, square root of 12. We did it on our warm-up. Square root of 12. We also did square root of 92, right? Anybody know that famous irrational number?
53. 34.
No, those are whole numbers.
No.
I heard it.
Hi.
Pi. Pi. Pi is an irrational number. Okay. So if rational numbers are numbers that can be written as a fraction, so 1/2 would be rational, right? 0.5 is rational. Are 0.5 and 1/2 the same thing?
Yes, ma'am.
Yes. Can be written as fraction. 2/3. 2/3 is also a repeating decimal. 0.6 repeating. Can negative numbers be rational?
Yes.
Yes. So negative 2/5 is a rational number. All right, I need y'all to see it. Okay. We can break this down more. Everything in here is less than 1, right? And we incorporated negatives. So to go one step further, we've got integers. So is negative 2/3 an integer just because it's negative? No. What would be an integer? -4. So they're kind of like whole numbers, but they can be positive or negative. So they can't be decimals or fractions, because that would make them rational, not an integer. So whole values that are positive or negative. What would be our next subset?
-5.
Whole numbers. And I'm going to expand to the last one because there's only a really, really tiny difference. Natural. What are the only, anybody know the only number that differentiates a natural? Negative. It's 0. So your whole number is 0, and your natural numbers are 1, 2, 3, because they can also be called counting numbers. When you think about counting numbers, when you learn how to count, and you were what, like 1 or 2 years old, your mom can come up to you and say, okay, 0, 1, 2. So all of these boxes are within each other, right? Which means that integers are also rational numbers. Whole numbers are also rational numbers. Natural numbers are also rational numbers. But it's not the other way around. So like -4 is rational, but it's not a whole number. And 0 is a whole number, but it's not a natural number. So everything that's within it, it's like, you know those nesting dolls? Have you ever seen those stackable dolls? And you take them out, and there's another one inside, and another one inside. Kind of like that.
How about the Mexico?
Okay, so natural, we're adding an extra bullet point here. Natural numbers are positive whole values one and on. So your next bullet point, blank are positive numbers and 0. Oh. Ooh. We're working our way back out of the box. Whole numbers. Blank are whole numbers and their opposites. So there you go. Integers. Blank is any number.
Rational.
There you go. Rational. Okay. And blank cannot be expressed as a fraction. Irrational. Real numbers incorporate all of them. So these are all real numbers.
Is there such a thing as an unreal number?
Yes, it's called an imaginary number.
Is it like actual,
Yes.
Like,
Like I squared is -1. I don't know why. Okay. So far, so good. So the only thing new to us, I'm out. The only thing new to us should be irrational numbers. Everything else is old news. It should just be a refresher. Okay, flip page. I've got some numbers. And I need to put them where they belong.
Oh, my friend.
Okay, Daniel, what you got?
Oh, 8/5 goes in rational.
8/5 goes in rational. Do you guys think that working with a shoulder partner, y'all can put these where they need to go?
Yes.
All right, I'm gonna let y'all do that. Okay, so we placed 8/5. 0. Hold. 23.
oh, I mean counting.
Add Natural or counting numbers. -17. Pi.
Irrational.
Oh.
-8. -5/8. Rational. That's not appropriate. 3.5.
Integer.
No, that's rational. 7.
Natural or no? Or natural.
It's a counting number.
And square root of 5.
Irrational.
Very good.
I got all those right except nine.
Right, I didn't.
3.14, whatnot. That's what we estimated at, but that's not what it is. There's a lot of numbers that we estimate. Have you ever seen on your formula chart where it says you can use 3.14 or 22/7? If you divide 22 by 7, it's also different than just 3.14. So we use those to estimate, but it's not the actual. Because you've seen this stuff about pi where it's like it goes on and on and on and on, and people try to predict like the first 100 digits after. Okay, at this point, we have about 10 minutes. Your homework and classwork, because you should get most of it done before you leave, is to check off on this page, and then, time out, listen. The last page, use all of the vocabulary words to write a paragraph about number 1. Okay. All right. Go for it.